And now for the next part of our discussion on optics, we have examples part 2. So let's have sample problem number 4. In the figure shown on the right, a ray of light is incident on face AB of a glass prism. Index of refraction of glass given 1.81. So you have a ray of light incident on side AB of the prism, and according to the figure, the light ray is perpendicular to side AB, which means the angle of incidence is 0. Determine the maximum value that angle phi can have so that the light ray will be totally reflected at face AC if the prism is immersed in water. So, the prism is surrounded by water. We have two media, the glass making up the prism and the water surrounding the prism. We are to determine angle phi. So, we have two media. Let the glass be medium 1 and the water be medium 2. So you have N1 and N2. N1, the glass making up the prism, and according to the problem, the index of refraction of glass is 1.81. N2 is the medium surrounding the prism, and that's water. We know the index of refraction of water to be 1.33. We are looking for angle phi. Now, the light ray incident on AB, as previously mentioned, the angle of incidence is 0. Sorry about that. The angle of incidence is 0, which means if we are to use Snell's law, the equation Snell's law will give us angle of refraction of 0 as well. Sine of 0 will give you 0. So which means the other sine theta will be equal to 0. Theta will be equal to 0. So the light ray incident on side AB, because the light ray is perpendicular to the side AB, the light ray will simply pass through the interface unchanged. The light ray will continue moving inside the prism and eventually encounter side AC, and according to the problem, the light ray will totally reflect at side AC. So you have reflection of light at this side. You have total internal reflection. For total internal reflection, Snell's law will give us N1 sine theta 1 is equal to N2 sine 90 degrees. The angle of refraction is 90 degrees, so that no light ray will be refracted. The light ray is totally reflected off side AC. Snell's law will tell us that sine theta 1 is just equal to N2 over N1. Theta 1 is equal to 47.2908791 degrees. Now, that's theta 1. We are able to get this angle. Note that for this angle, we have a triangle which is similar to the triangle of the prism. You have similar triangles, which means whatever the angle here is also the angle phi. So phi is just this angle geometry tells us phi plus theta 1 is just equal to 90 degrees. Thus, we are able to determine phi knowing what theta 1 is. So, phi is equal to 42.709 degrees. Next up, we have sample problem number 5. A curved mirror is used to produce an image of a toy car. The image has a height of h prime is equal to 0.4 h, where h is the height of the toy car. If the mirror has a focal length of 40.0 centimeters, absolute value, determine the distance of the toy car from the curved mirror. That is to say, determine the object, distance S. Is the image formed real or virtual? What kind of mirror was used? That is to say, is F positive or negative? We are given h prime is equal to 0.4 h. So let's use the lateral magnification equation. M is equal to negative S prime over S is equal to h prime over h, which will give us S prime is equal to negative SH prime over h. H prime is just equal to 0.4 h. We can cancel out h, which gives us S prime is equal to negative 0.4 s. Since the object, the toy car, is a physical object, likewise, since you have one object, one mirror, the object must be in front of the mirror. S is positive. Object distance is positive. The object is in front of the mirror. Since S prime is equal to negative 0.4 s and S is positive, this means that S prime is negative, which tells us that for a mirror, S prime is negative, you have a virtual image. Using the equation for image formation, 1 over S is equal to 1 over F rather, is equal to 1 over S plus 1 over S prime. Rearranging, we have F is equal to S prime divided by S plus S prime. Knowing that S prime is equal to 0.4 S, we are able to determine that F is equal to negative 0.666 and so on S. And since S is positive, this tells us that F is negative. For a mirror, F is negative, you have a convex mirror. So we have answered the last two questions. Is the image formed real or image? The image is virtual. What kind of mirror was used? Convex mirror. Or all that's left is determining the distance of the toy car from the curved mirror. Determining the object distance. Absolute value of F according to the problem is just equal to 40.0 centimeters or 0.4 meters. Which means F is just equal to negative 0.4 is equal to negative 0.6666 and so on S. F is equal to negative 0.666 and so on S. Rearranging, we get S is equal to 0.4 divided by 0.6666 and so on, which gives us S is equal to 0.600 meters or 60.000 centimeters. And that's it for now. That's it for our discussion on examples part 3, part 2 rather. We'll finish up our discussion in the next video wherein we take a look at examples part 3. So again, that's it for now and thank you for watching.